Hey, it's Dan here. Welcome to Fun Kids Science Weekly Reach for the Sky special, the podcast that's exploring the future of aviation, from the design and sustainability of future planes to the people who keep them flying and make sure that your experience in the air is top-notch. In this podcast, we're meeting Rolls Royce. Now, you might have seen some amazing Rolls Royce cars around and about, but Rolls Royce isn't just a car brand. It's also a world leader in making mega powerful engines for airplanes, ships, and even space projects. For 100 years, Rolls-Royce has been inventing incredible machines that help people travel safely, swiftly, and more sustainably. Rolls-Royce is designing cleaner, greener engines using sustainable aviation fuels because even powerful engines need to be planet-friendly. Most of Rolls-Royce's jet engines are made in Derby, in England. During World War II, the legendary Merlin engine helped power the famous Spitfire planes. Today, they're building Trent XWB engines for big jets and working on the Ultrafan, their most efficient engine yet. And as well as making things in the UK, Rolls-Royce also build parts in other places around the world, like in Singapore, where it makes special hollow titanium fan blades. Titanium! Also, there it tests engines that roar like thunder. So, whether it's the skies, the seas, or the future, Rolls-Royce is helping power the world forward. But to start us off, technology is becoming super important in the development and maintenance of aircraft and keeping planes flying safely. And that includes AI. And to tell us a little more, here's Amy.
Amy Aviation, reaching for the sky.
Hi, Amy Aviation here. Today, Zac and I are diving into something cool and clever and sounds totally futuristic. It's artificial intelligence. It's one of the several new technologies that's helping make aircraft and airports smarter, safer and greener. First stop, air traffic control. Airports are busy places and the skies above them are even busier. Around 2.6 million planes fly each year through UK airspace, and there's increasing demand for more flights from a wider variety of aircraft. And that's where AI can help. It can look at weather, air traffic and flight plans all at once and help choose the best route for each aircraft.
Kind of like a super smart sat-nav, but for planes. In 50 miles, turn left.
Exactly. AI can process an enormous amount of information and learn to spot patterns, helping air traffic controllers plan flights and make the best informed decisions to reduce delays, avoid storms and save fuel. Now, before and after any flight, passengers will make use of the terminals, and that's our next stop. AI is already hard at work helping passengers move faster through the terminals, streamlining check-ins, security clearance and boarding processes. AI-powered biometric systems can help with facial recognition to speed passengers through the terminals without needing physical documents. AI can also help manage passenger flows, spotting when terminal areas get crowded and, say, open more security lines to stop long queues.
So no more standing forever behind someone who packed 6 bags but forgot their passport.
Sadly, AI can't help there, but it is helping make baggage handling smoother, tracking bags in real time to make sure they don't fly to the wrong holiday. Behind the scenes, AI can help airports run like well-oiled machines, with high-tech cameras spotting unusual activity and anything rather strange.
Is that a squirrel on a suitcase?
Squirrel detected.
But AI doesn't stop on the ground. It's heading to the skies too. Meet a future of flight. Self-piloted planes. Thanks to AI, not only might the autopilot help fly planes once in the air, it might also help them take off and land. AI can even help make aviation more sustainable and improve fuel efficiency. By analysing aircraft sensors and flight data recorders, as well as weather, flight routes and passenger load, AI can optimise fuel consumption. One tool can even help reduce fuel consumption by suggesting an optimal climb speed during takeoff.
That's what I call high-flying climate action.
And here in the hangar, AI can help engineers improve maintenance and get planes back flying quicker. It can track aircraft components in real time, forecast faults, and even plan repairs whilst a plane is in the air. This will help reduce downtime, cut repair costs, and improve operational efficiency.
That sounds super efficient.
AI and tech can also help out on the runway, where a defect or object could result in passenger delays and be a potential risk to safety. So imagine if you could digitise the runway with a virtual twin, helping airport management to pinpoint areas requiring attention and schedule maintenance. And by using remote sensing, objects that shouldn't be on a runway, like a bolt or even a dead animal, could be spotted quickly and removed. But we have to remember that AI is powerful stuff, so it's really important that it's used safely, ethically and responsibly, and that through cybersecurity it can't be hacked. That means making sure it helps everyone, works fairly and always follows the rules. So, to sum up, AI is helping airports and aircraft become faster, safer and greener, using data to help human operators make informed decisions and help develop new innovative ideas. From smart bags to flying bots, the future is looking bright and brilliantly brainy.
Amy Aviation, reaching for the sky. Created with support from a CAA Reach for the Sky Challenge grant. Find out more at funkidslive.com/Amy.
Thanks, Amy. To find out more about Rolls Royce engines, I met 2 aerospace engineering degree apprentices at Rolls Royce. Thanks for joining us, guys. So to kick us off, can you both introduce yourself and explain a little about what your role is?
I'm Neha. I'm a aerospace engineer who joined Rolls Royce through the degree apprenticeship scheme. So at the minute, I'm just finishing off my program. So I'm currently working as an air safety investigator.
I'm Harris. I am an engineering and technology graduate at Rolls Royce, again Bristol and defence. And yeah, it's a scheme where you move around different placements within the business, and currently I'm in a team which is looking at our ADOR engine, which is on the Hawk aircraft, and that team is focusing on the life cycle engineering side of things.
So Rolls-Royce is an iconic company, although lots of people think of its heritage with luxury cars. You guys are working on much bigger engines, aren't you? What sort of things does your day-to-day work look like on the aviation side?
I'd say for me is that no day looks the same. So within the role that I'm currently in, we look at what has made the engines go wrong and what could go wrong with the engines. So it could be different accidents or just different investigations that have occurred, and we found there is a safety issue. So then we have to go back and almost work backwards to try and figure out what caused that and whether it's a bigger issue or an isolated issue. So yeah, I definitely say it's just that no one week looks the same.
For me, my current role makes it quite exciting as there's a good bit of exposure to the hardware. So I think it can be quite common within some engineering roles where it's quite office based and you're kind of remote away from the actual physical hardware itself. So the current role I'm in, I get to go and see some of the parts of the engine, see if there's any issues with it, and then sort of go back and make, I guess, our chief engineers and other senior managers aware of any potential hazards or issues that there might be.
And then what? What kind of engines, what kind of planes are you working on at the moment?
So we are both defence. So we're working on sort of, jet engines within defence. Like I said earlier, the aircraft I'm looking at is the ADOR engine. So that's the one that's in the Hawk aircraft, which most people know as the Red Arrows. So that's the one that I'm focusing on at the moment, but I'm not sure what Nea's.
I think for me, it varies a lot depending on what investigation we're doing. So right now I'm also looking at ADOR engines, but previously I've worked quite heavily with EJ200s as well. So they're the ones that power our Typhoons.
That's cool. Must be incredible to have landed careers like this. And if you don't mind me saying, at quite a young age, could you give us an idea of your path to working at Rolls-Royce?
Yeah, I can go first. So I think it's probably a bit of a classic. I was reasonably good at maths and physics, and then as a result, it's one that seems to sort of always lean towards engineering. And then, yeah, I was quite interested in designing. So actually, my degree is in product design engineering. So I think that's what's quite good about Rolls Royce is you don't necessarily need an aerospace or a mechanical engineering degree. They're quite accepting of a range of different STEM degrees, especially coming into their engineering and technology programs. So I think that was what initially pushed me to Rolls Royce, though, was I'd had previous work experience within a defence company, and it is a place where within defence a lot of new and novel technologies are being developed, and I think that was what had drawn me to defence specifically. And yeah, I mean, Rolls Royce is quite a well-known company for having a good track record with its employees, so yeah, I was just very keen to apply there.
I think for me, it was very similar with the maths and physics, but then I'd also done a lot of DIY stuff growing up. So it was a lot of like household jobs, whether it was like fixing a radiator or like fixing a door or something. So a lot of the problem solving came into that. And then Rolls Royce was actually the only company I applied for my degree apprenticeship. And then I think how I ended up in defense was just looking at afterburners and thinking like they're really, really cool and I just want to be part of them. So that's how I ended up there. And then I applied in my final year of A-level, so year 13, and then joined the summer afterwards. So instead of going to university, I just moved over to Bristol and then joined the company at 18.
So your paths were similar at the outset in terms of your skills and interests, but a little bit different in the way you joined the scheme.
So I did 4 years at university, which is, I think, a standard for an undergrad up in Scotland. And then I took a year out to do an internship. So I got an internship at Rolls Royce for a year, went back to university to get my master's, and then joined back on the graduate scheme. So that was my route, which is slightly different to Nea's.
Amazing. So we've been looking at the future, but let's take a moment to step back and check out one particular innovation from the past. One of the most famous creations from Rolls-Royce during World War II was the Merlin engine, which powered many famous planes like the Spitfire, Hurricane and Lancaster bomber. It's a supercharged liquid-cooled 12-cylinder engine with pistons that move up and down, turning a crankshaft that spins a propeller. The early Merlin engines had issues with the carburettor. This resulted in the engines cutting out during combat, which could prove a real issue for even the most skilled of pilots. However, an engineer by the name of Beatrice Schilling invented a restrictor that prevented the engines from stalling and, as such, improved the engine. Production ceased in 1950 after almost 150,000 Merlin engines had been delivered, but they still remain in service today with the RAF's Battle of Britain Memorial Flight, as well as privately restored aircraft. Brilliant. So we might be finding out about all things sky high on this podcast, but we like to stay grounded too, and our listeners have been sending in their questions for you. So let's get back to basics. Here's the one that most people have asked. How does a jet engine actually work?
Okay, so a nice little phrase that we have whenever describing this is suck, squeeze, bang, blow. So the main thing that all engines need to do is to take in the air. So that's the suck portion of it. So you'll have a fan intake at the start, which is responsible for kind of drawing all that air in. And then what we do is using compressors, we squeeze the air down as much as we can to get a very, very high density of the air. And then as it travels through the engine, it then goes to our combustion unit, which is where it goes bang. So we add a bit of fuel in and then ignite it. And then as it ignites and as the temperature increases, that really, really dense cloud of air then expands rapidly. And then as it expands, it pushes out towards the back of the engine, going through our turbines, which helps create the blow effect, which is kind of just making the thrust happen by taking all this expanded air and pushing it out. So I guess a similar comparison to the blow bit would be if you blow a balloon and then let it go, how it goes flying around the room. So that's essentially what's happening within our engines, just a lot more controlled.
So designers are using those basic principles to make planes?
Yeah, I think we spoke about this one, and it's like there's so much, but I guess I'll try and summarise it as best as I can. So I guess at the start, you're given a design brief by your customer. In our instance, it's very much the UK MOD a lot of the time. From there, you then, you go to designing. So it can be start from sketching, which can then translate into computer aided design models. And then from there, you might look into doing some sort of, what's the word I'm looking for? Sort of like testing through computerized testing. So you'd be looking at maybe some stress models to make sure that actually some of the design would be robust enough to withstand some of the loads that it'd be experiencing, but then also some computational flow dynamics work as well, which is making sure that actually the part would work and some of the parts performance features would actually function as well. And then from there you go and actually do some testing and designing and building. So maybe do some prototyping, test to see if it actually works, and then inform your design decision. So it's a bit of an iterative loop. It's definitely not like a straight line process. It's a lot of design, test, design, build, test, and backwards in a bit of a loop to inform your decision. And then eventually you come out at the end with hopefully quite a refined product which meets your customers' requirements and a full-scale engine at the end.
Next question from the listeners then. How long does it take to make an engine from a new design?
It definitely varies, but I mean, so take our new, the main thing that the Bristol site's working on at the moment is the Global Combat Aircraft Programme. So that's a 6th generational platform, I think they're calling it, aircraft. And it is, I think since start date to when it's going to be in service, it's going to be around 20 years. Is that right, Nia? From like the initial launch date, 15 to 20 years. So the in-service date is 2035 that we're looking at, but I think the launch date was 2018. So yeah, nearly 20 years.
Does the production process differ depending on what you're building, or is there some sort of similarities across the project?
There are quite a few similarities. I think the main difference would be what the purpose of the engine is for. So quite often with the engines that you'll typically see on your Ryanair flights or British Airways flights, they're all quite similar in that they don't have a afterburner system. They don't have the exhaust system. So then you can almost use previous models as a baseline and then build on that. Within defence, it's a lot more... We don't create the engines as often. So whenever we do start it, it's starting from near ground zero, just taking the knowledge that we previously have and then having to adapt the system to whatever the customer is after.
Right, okay, so that makes sense. And next question we've been asked to put to you. How many engines do you build every year?
We looked at our annual report for 2024. So within defence, we managed to deliver last year across our whole defence sector. I'm just looking at the numbers now. I believe it was, 549 aircraft that we delivered in 2024. So that's also with our US defence site as well. So I think, across the whole defence business, that was what we delivered. We've also got our civil side, but I'm not entirely sure on the numbers on that.
And then this was an interesting one, and one I had to scratch my head about. How many engines are there in a plane? I'm thinking 2, but I imagine it's probably not the same for each plane. Is that what it is?
So it does vary. So if you look at, say, the A380, where it has 4 engines, whereas a lot of our civil planes have 2. And then when you compare that to the Hawks, which are used by the Red Arrows, they've only got a single engine. So, yeah, it very much depends.
And here's another question our listeners have asked. What's the largest and most powerful engine that has ever been made?
Okay, so we might have to both answer on this one because I can't remember the stats around it, but the Ultrafan is a new engine that was designed, I think, 2 years ago. I think we created the first version. So to give a bit of context, it has a diameter of 3.5 meters, which is quite a large engine, and I think we're currently looking at taking that to market, single body aircraft market. But in terms of the thrust, I don't know if Nia can remember exactly what the thrust values were.
It's about 85,000 pounds of thrust when running at full power. So yeah, it can very much vary. It's probably our most powerful by far.
We've actually got a couple of questions on fuel now. Why is it important to develop new types of fuels?
Yes, I think it comes back to the sustainability message, and obviously net zero by 2050, and there's a lot of policies that the UK government are putting in place. So I think a lot of our work and designs are trying to be driven towards using more sustainable aviation fuels. I think within the civil aerospace, especially for Rolls Royce, that is that's very much feasible. I think all of our aircrafts now run off SAF, sustainable aviation fuel, and I think it's something that we're working towards within defence. But those jet engines just make it a little bit more difficult due to the design and the nature of them to use SAF.
And then, how might new fuels change the face of aviation? So when you're designing these planes and building them, if you're using different types of fuel, is that going to affect how you design the planes and how they might look once finished?
Yeah, so we think it definitely will, especially if the fuel that you're now using is no longer liquid. So at the minute, the way fuels is stored, it's in the wings of the aircraft. So then if you no longer have this liquid that can't fill up the wings, you say might have a storage container that goes at the back of the plane. And if you have that, one of the big considerations is your weight and balance then changes. So you may need to have something at the front to then counteract that change in weight. And that could change the aircraft as well. So it would depend on what medium of fuel that you're using. But it is very possible that the shape of planes can change. I think the other factor would be is if you can find something that provides a lot more power than our current fuel systems can, then you may not need the most aerodynamic shape to then be able to overcome that. So then you could maybe one day have a circular plane even. But yeah, future's the limit, really.
And how soon might we see these new planes with new sources of energy?
I think it's quite hard to say, especially within defence, to be honest. I mean, yeah, they're definitely looking into them. There's a lot of work been done into how to incorporate them, but it's that balance of actually the performance features versus the sustainability. Now, obviously, in an ideal world, you do both, but yeah, I think civil aircraft, it's very much feasible, but due to the nature of a jet engine, it's just a little bit tricky to put a time scale on and how or when they would all be incorporating sustainable aviation fuels.
So hydrogen is one of the hottest topics in how we power planes in the future. But I've been finding out there are other ideas in development. Are there any front runners?
Okay, so starting with sustainable aviation fuels, I'd say it's the most immediate one that we can bring into play. So quite a few airports are already using it. Quite a few companies are using it. I'd say right now, one of the cons of it is that not all aircraft can use 100% sustainable aviation fuels, which goes into the whole chemistry of why that can't happen. But I'd say that's a limiting factor at the minute. But it's a very big positive, and it is probably the most immediate solution that we could have. Harris, do you want to take batteries?
Yes, so batteries, yeah, we spoke about this. So yeah, would be great, but it would be great to obviously put all batteries in all aircraft. But the pros are that you're not burning potentially, hazardous or fuels with toxins into the atmosphere. However, as we're probably aware, and as you see within cars, some of these batteries can bring their own dangers, especially if they caught fire or they leaked. It could be quite detrimental to the aircraft. But additionally, the weight is also a consideration with batteries. So if you were wanting to fly one of these aircrafts that we have at the moment that carries a door engine, the size of that battery would be, you couldn't even picture it. However, I think one area that batteries could be focused in the future would be something like drones or unmanned aircraft. So that is something that potentially, in the near future, the batteries could be used in.
And what about nuclear power? Is that something we might see in aviation of the future?
Yeah, I mean, again, it might not be the best answer. Very briefly, we've got like a novel nuclear sector, and I think they're doing a lot of work in it. Equally, we had a big contract recently for small modular reactors. However, I think that's more geared towards potentially space space aircraft rather than jets. But yeah, again, we're not overly sure about what's going on in that space. We're quite separate in that way in Rolls Royce.
So, as we're finding out, there's a lot of exciting new developments out there in the sector. And another hot topic that everyone's talking about is AI, artificial intelligence. Is this something that your sector is making use of? What are the pros? What are the cons? Take us through it.
Yeah, so I think AI, it has a lot of positives. It has a lot of contributions that it can give. Within the defence sector and possibly within Rolls Royce itself, don't use any of the current open source AIs that exist, because a lot of what we do is what we call intellectual property. So we can't go sharing that online and have someone else take it just because of the nature of the business. And on top of that, within defense especially, we work for a lot of different governments and a lot of countries. So then we don't want to be putting information that these countries are then going to use online. So the security aspect of AI is quite hard to balance at the minute. We are looking at possibly developing something in-house and making it useful that way. I think AI could definitely help with a lot of admin tasks that engineers have to do as well, which is quite often not spoken about. So I think it does have a lot of potential, but it's unlikely that we'll use something that is openly available on the internet.
So that makes sense. Yeah, and I appreciate you can't give us all the details because you need to keep security in mind. But can you give us any examples of how it might be used, say, in the design process?
I would say AI could be used to possibly collate all the information to do with what is the most aerodynamic shape. So that can take some of the information from, say, looking at birds, how their wings are made, and then seeing how we could possibly implement that within our designs. A lot of the challenges that we're facing when it comes to aerodynamics is already there in nature. So it can help collate all this information and help us create a new design and consider possibilities that haven't been looked at before.
On top of that, as Naya was saying around the design, I know AI can be used to generate a number of different concepts in one go. So it could be something like that in the future where you have an initial set of requirements that you plug into AI and it spits out a range of different designs that you wouldn't have even considered in the first place. And that's certainly a way that it could be used in the future.
So, because you are so lucky in having these jobs in the industry, we thought we'd swoop in on a job right at the centre of things that we've been talking about. Aviation, sustainability, engineering. Let's find out more. Ever dreamt of helping planes fly cleaner, quieter and greener? Well, that's what aviation sustainability engineers do. They're the planet-saving problem solvers of the sky, designing clever new ways to cut emissions, use cleaner fuels and build engines that won't cost the Earth. Literally. You could be working on the UltraFan or developing sustainable aviation fuel, and not forgetting smart robots to check engines for wear and tear, saving time, energy and emissions. But how do you become one? You'll usually start by studying maths, physics and design at school and going to university for aerospace, mechanical or environmental engineering, or doing an apprenticeship in engineering right after school. And the best part? You could help invent the engines of the future, where jets zoom through the clouds to help aviation reach net zero by 2050. I've got a couple more questions from our listeners, if that's okay. What's one of the coolest things you've ever done working in aviation? I guess you can both answer these questions.
I'd say for me, it was working on the engine testbed where the Concorde engine was actually developed. So I was positioned there for about 8 months, I think it was. And then I got to help lead some of the engine testing and then seeing the actual afterburner kind of ignited right in front of me, and then seeing the diamond shape that you get on the back of an EJ200. So I think that's definitely been the coolest moment for me.
And I think for me, it was being exposed to additive layer manufactured technology, so 3D printing. So we're looking at 3D printing some metal parts that are part of the engine. And yeah, I got to take them up to a testing facility and hook them up to a rig and extract the results out of it to see how effective they were in comparison with how we would normally manufacture that part. So that was really, that was a really good experience.
Next up, favourite airplane?
I'd say for me, it's the Airbus Beluga. I just love the way it looks, and especially when they paint on the smile that it has, and then seeing the head open up and everything. It's just a really cool plane.
And I think I'll be biased because I've been working on it, but I do quite like the Ador engine. I think the fact that it's on the red arrows and we're all quite aware of what that is, and the fact that it's a single aircraft and it was designed and first put into service in the 60s, and here it is still going. So yeah, I think I'll go with that one.
And then as an engineer, what's the most interesting part of the plane?
I think we'll be biased, but it is the engine. I imagine if you spoke to people from Airbus, they would tell you it's the airframe, but yeah, we'll tell you it's the engine.
And if you were going to design a plane in future, what would you make sure it had or could do?
Oh, sure, really. That's an interesting question. I think a lot of the capabilities currently on aircraft are really, really kind of there and good. I'd say for me, it would be involving the idea of autopilot or an AI control system to help best manage the actual flight path that you're using. Because then I think that would have a ripple effect of how much fuel you're using and like where you need to go, what heights to travel and things like that. So it would be quite cool to embed the technology using live data into the actual aircraft.
I'll build on my previous answer around 3D printed parts. I think it would be really, again, maybe not completely feasible at the moment, but it would be really cool in the future if, instead of having to use some of these manufacturing processes such as casting and forging, and we could actually just 3D print all of our parts. Not only would it save amount of time, but the amount of material that you would save and prevent having to go to scrap. I think maybe that's quite a boring engineer's answer, but that would be quite a cool design feature in the future for planes.
And we asked you to tell us the craziest fact that you knew about aviation. What did you come up with?
I guess one that's maybe not as related to the actual engineering side of it, but when you're flying, the reason that airplane food often tastes quite bland and quite boring is because your taste buds are essentially desensitized in the altitude. So then some of your favorite snacks on the ground could be really, really boring and distasteful when you're up there. So I think that one always shocks me, especially like every time I go traveling, I'm like, wait, something's gone wrong here kind of thing.
I don't think any of us knew that, did we? But now we do. Amazing. And we asked you to pick out one of our listener questions. And I see here it's the one about how many people have worked together to make one type of plane. What's the answer?
Pulling on the project that Harris mentioned earlier of GCAP, I think we have around 10,000 people across the 5 organisations in the UK alone. So then when you take in the people who will then be involved in manning the actual defence sites and then the pilots who will eventually fly the aircraft and the maintenance crew, the number can probably double. And then this aircraft is likely to fly for the next 30, 40 years as well. So there's probably quite at least 100,000 people who would be involved in a single aircraft over its lifetime.
That's incredible. And as we found out, things are changing, which means lots of new roles in the future. We're nearly out of time, but here's something we wanted to ask you. If you look back at planes 100 years ago, they're pretty different to what they are today. Do you have any idea of what they might look like in 100 years? You know anything on that? It's probably quite a hard question to answer.
If I'm being imaginative, I think it'd be quite nice to think that, yeah, they would be unmanned. Who knows that, but I think it could be possible, especially for defence aircraft, that they could become unmanned, because at the moment you only have 2 pilots in there at the most. So maybe that is something that's possible. But in terms of like a civil aircraft, such as your EasyJet flights or something like that, I think it could be difficult. But who knows? In 100 years, it would be nice to think that these aircrafts are being unmanned and it's all done completely by future technologies and robotics. That would be a nice state to be in.
Robo pilots. I love the sound of that. But what about a flying hotel, like a cruise ship, when the sky is up? Is that going to be possible?
That would be nice, wouldn't it? A little flying hotel. Well, I mean, yeah, aircrafts are. I don't know as much about civil, for being honest, but they're developing. I'm imagining that they are going to be able to hold more and more. Especially as engines develop and they're able to provide more thrust, you would like to think that they'd be able to hold more weight. Whether that's a hotel that can go up into the sky and just sit and chill for a bit, I'm not completely sure, but maybe in the next 100 years that would be something that could happen.
Well, thank you for that. And with all of those questions answered, it's time for us to head to departures. But we hope you can join us again soon. Fun Kids Science Weekly Reach for the Sky special, created with support from a CAA Reach for the Sky Challenge grant. Find out more at funkidslive.com.